Well, good afternoon, and thanks so much for joining us today for another great Salty Dog webinar. This is Barb Tyson, and with us today we have Lance Vickery from Victron Energy, who will be talking about power management. And I think he's going to talk a little bit on the latest updates on power sources, charging options, and sizing. And a few reminders, as always, before we get started. Let's keep muted and video off. But go ahead and type your questions in or any comments you have for Lance in the chat box that I've opened. And now I'll hand things over to Alex Helfand, our Salty Dog Education Coordinator.
Thanks, Barb, and happy 2022 to everybody. Victron Energy is one of our Salty Dog sponsors, and admittedly, when I took on this role, I was thinking of topics that would help all of you as well as help me. And when I look under the master berth on our boat, which is fairly new, it's got lots of blue Victron boxes in it. So selfishly, I thought this would be a great topic for us. And so Lance is going to talk about onboard power management in general. And if you have questions specific to Victron or other systems, please feel free to put those into the chat. I'll also remind everyone that Lance is going to join us on Thursday at the Ask the Experts webinar. So if you don't have a question today or aren't sure how to phrase it, just be prepared with it on Thursday. And with that, I'm going to turn it over to Lance.
Great, thanks, Alex. So quick introduction. I'm one of the sales managers for Victron. We have 5 of us across North America now. Victron's grown quite substantially in the last few years. It's always been quite prominent in Europe, but we're making great inroads into North America, especially with the RV and off-grid and what have you, that sort of stationary power, or land-based, should I say, instead of water-based. So we've done we've been pushing into those industries as well, but don't be worried. We haven't left our roots at all. We're still doing lots of onboard power management. So what I've done today is I've just put together, hopefully, I know about 40 minutes or so here of a quick PowerPoint and just going over some basics. Usually what I have found in the past is people start with the idea of getting lithium batteries and going crazy from there. But really, when you're doing a power management system, you should really start at the basics and understand what you need before going on to specifying your actual components and things like that. So you'll have to excuse me if I mess things up. Barb will help me out, I'm sure, but let's get going on this. Of course, power management's always been done a few ways. I'm sure a few of you have seen these lovely analog voltmeters and amp meters that you can look at and try to guess the state of your battery charge. This is typically what onboard people are looking at. We have a battery bank. It's supplying us with power to do what we want to do on the boat, be it curl our hair, make coffee, or run the radio. So these are the sort of systems that we've always used. It's been things like the voltmeter and the ammeter to sort of get a basis of what's going on. A number of years ago, we introduced our battery monitors, which you see there. This, in this case, I'm just showing a smart battery monitor. Smart meaning it's got Bluetooth in it. All of our battery monitors are just this one has Bluetooth in it. And the nice thing about these in battery monitor, and you see I've also highlighted the one below from Blue Seas, is that you get more information. You're able to not only get the voltage and the amperage that's going through your system, but often you're going to get a state of charge, which is really what you want to be looking at. You want to know that you're never running out of battery power, or when you are getting low on battery power, and when you are, to mitigate those draws on your system. Often, for me, I use the 712 quite a bit, and I love it because I just always turn it on to time remaining. time remaining until my batteries are at a point where I have to recharge or can't use them anymore. And of course, those parameters are changing all the time, especially with new types of batteries. Typically, if you're looking at a lead-based system, we've always been talking about basically a 50% discharge. Typically, a lead battery at 50% discharge is sitting at 12 volts. That's where industry standard says the battery is discharged and should be recharged. When we drag lead-based batteries below that, then we start affecting their life cycles. And life cycles mean the shorter we use that, the more often we're replacing the batteries, and really don't want to replace the batteries more than we have to. We've been talking about, I know I'm from the Pacific Northwest. Quite often we're looking at 5 to 7 years for batteries. I'm visiting down here in Florida right now, and people keep telling me it's 2 years, maybe 3 if you're lucky. And that has a lot to do with how much is discharged, but also the heat of the batteries and the surroundings. So we can look at a few ways to fix that. You'll notice here I've just as power management. So we started off simply. Now we're getting into all sorts of wonderful ways to look at our power and what we're doing with it. You'll see the little blue C's, the multimeter there that shows everything that's happening on both on your AC side and your DC side. Start batteries. I've also highlighted here our new Servo with its touch screen. As you can see, it's got you can see the power you've got from the grid, your AC loads, and all the other devices that that could be connected to it. All right, let's keep going here. Typically, for power sources, I'm sure you all kind of get the picture here. Sorry about the pun. Obviously, we've got shore power, the grid, generator, solar power, alternators, wind power. Obviously, we're storing all that in batteries. And of course, there's also tow generators and other propeller-driven charging devices or power devices that we can use while we're on board. And the biggest trick here is to manage all these devices so that we're always using the power that we need, or we have power that we need available, and also so that we're not over or undercharging our batteries, because that is what will really give us the longest life in going about having power on board. Obviously, when we're talking about shore power, we're using it to either direct use or to get into chargers or inverter chargers. Generators, we're often doing the same thing. Generators are more often power for air conditioning units and what have you, but also for backup and standby. Obviously, we're getting alternators, which we'll talk about a little bit more here in a bit. Alternators are, everybody tends to have one of those on their auxiliary or their main engine. So we've always got their standard alternators. There's you'll notice that more and more of the high-tech diesel engines will be now coming out with smart alternators. You can always get high output alternators. Balmar makes a whole bunch, and almost everyone does now, as well as alternators that are externally regulated, which we'll talk about in a moment. Obviously, the wind and water generation, as many of you know, that we've got to be careful with that. Obviously, you don't want a wind generator in the way of your rigging and what have you, but also remember that just because you're out cruising in the trades, if you're happen to be going the same direction the wind is, you're not going to get a lot of wind power. You need a very decent apparent wind across the wind generator to create power. So great when you're anchored and sitting in the trades, maybe not so great when you're on a broad reach running somewhere. So that's always the other thing with the water, which I've experienced with. It's great, it just keeps running and running all the time you're moving. It does take a little bit of drag depending on the size of the boat, and you've always got that another appendage hanging off the boat. Of course, we get into solar, which is our favorite. We've seen a huge increase in solar power in the last 10 years. The fact that the solar panels have gotten way more efficient, so their sizes come down. Plus the advent of MPPT charge controllers, meaning we're getting about 30% more yield out of the panel than we would have before, means that the solar is a great option. We're usually out on our boats when it's sunny, or hope to be, so that makes a nice use of power. And don't forget, of course, that we only get it about 12 hours a day. I've always calculated it at 6, but you have to be quite aware of that. Let's keep going here. Of course, the ways we store power is golf carts, and yeah, tried to be a little levity here, but you know, your typical flooded lead acid battery, AGMs, which are just a valve regulated lead acid battery, so it's a sealed battery. AGMs and gels are great because the electrolyte is bound to the whole cell, as opposed to the cell having different levels of it. So typically an AGM or a gel is a really good a good storage facility for power, but none of those, whether it's lead acid or the AGMs, like to be sat in a partial state charge. So that's a really big thing that happens to boaters. Get the wonderful sulfation in these batteries when we use them at partial states of charge all the time. Never really getting that sulfation off the plates, and that's what deteriorates a lot of power, or the ability of the battery to store and release the power. A couple new ways of doing this. Well, we're still sort of gone from least expensive to most expensive here. Are the new lead carbon and thin plate pure lead batteries. They have a lot lower internal resistance, which means we can get power in and out of them a lot easier, which means that they're a little easier to charge, or we can actually charge them at a better rate. And also those batteries offer a very low self-discharge, where you put your golf cart batteries in there and you come back 6 months later and you notice that they're half gone. Lead carbon battery, originally, Caterpillar was a lead designer of that, looking for a battery that would could stay out basically out in the woods in the construction yards for half a year and still be able to be started. So lead carbon is a really good thing for that. We've also found that it is very good operating at partial states of charge, which is quite significant, because that's how a lot of us use our batteries. We're never getting them right back up to a full state of charge, especially if we're out for longer than a few days. So those batteries have a lot of advantages. Plus, they're still less expensive than getting into the sort of what we're looking at as the gold standard now, the lithium. Obviously, the nice thing about lithium is it's got a very stable power curve. So we're looking at, you'll watch a lithium battery sit around 13 volts for what seems like forever before it starts dropping. And of course, that's very nice because all of your devices love that kind of stable power and higher power. So be it your windlass, be it your electronics, all those things operate so much better. Inverter chargers also much better with a good stable voltage, as opposed to having the voltage drop quite drastically when there's a large load on it. Also, lithium batteries have an extremely low internal resistance. That is why we can charge them so well. That's why they are very happy at a partial state of charge. In fact, probably happier discharged partially than they are fully charged. But it also allows us to discharge them at a higher, longer sustained rate without a huge voltage loss, or voltage change, I should say. I have played with a couple supercapacitors. I don't know where they're going with supercapacitors yet. They're kind of, I think they're still big, and you can get some interesting ones. but it's not a technology that Victron has dove into yet. So I think we can put that off for a while longer. I think what you're going to find is that both the better class of lead batteries and the lithium will really be the place where everybody will be going in the next, I would think, foreseeable 10 to 15 years. Of course, with our lithium, we should be able to get that 10, 15, maybe even 25 years out of it. But how much, someone asked me the other day, how long are your batteries good for? I had to tell them I don't know, because haven't got to the end of their use yet. It's really difficult to put 5,000 cycles on a battery. And if you can, it's taken you several years to get there, even if you're doing it every day. So yeah, so how long will lithium last? Time will tell. So, and Barb, just a note, if there are questions coming up or something, I don't have my chat on, so let me know.
Yeah,
I've
I'll
also,
keep an eye, Lance, I'll keep an eye on the questions.
okay, thanks very much, Alex. Also, in doing this and having spent the last 8 months traveling around North America doing training in that for Victron, I've come to find that we start looking at putting our power management system in the boats, because it's kind of like putting new electronics in. It's kind of fun, and all these gadgets are really great. But what I have noticed is that a lot of people are not really doing any sort of not necessarily management, but a real idea of what their power is needed on the boat. And so I really encourage all of you to do a power assessment, meaning, and I'll show you down, I've done a really cheap and dirty one below here, but we'll show this first. The power assessment, meaning looking at all the devices you have on the boat, and figuring out how much power they're actually using, and how long you're using them. So how long do you use your air conditioner? How long do you use your navigation electronics? How long are your nav lights on? How long is your anchor light on? How much is your stereo drawing? And how long do you use it? Refrigeration, big power use on, well, sustained power use on boats. How much power is your refrigeration using? Do you have an ice maker? Do you have a freezer as well? Add those things up. How much are you drawing out of that? Also, you really have to consider what you want to add in the future. Maybe not, maybe we're not necessarily talking about like 5 or 6 years out, but in your foreseeable future, what do you want to add to your boat? And it's a lot less expensive to accommodate that when you're designing the system than to add to it. If you're thinking you're going to run a few air conditioners and you want to run it off a battery bank, then start considering having enough inverter power to do that from the beginning, as opposed to trying to add it after. As I'm sure many of you know, trying to shoehorn extra batteries and extra inverters into a boat is always difficult. You're always going to compromise something. You've got to give up something to get that space. The other thing I ask people to do is really estimate how much time they're using their boat, like, and how they're using the boat. Are you going on an extended cruise? Do you use your boat every weekend? And do you use it on the weekends, and do you put it back at the dock? So, it's sitting at the dock for 5 days, and then you take it out for 3 or 4 days, and then it comes back and it sits back on the dock, and you have power. You're able to plug it in. Those are all things that you want to know and add into your power assessment when you're doing that on your boat. Of course, how do I measure? I measure in watts, because that way I can use the voltage that's on the boat or that the appliance is using, and we get a wattage at the end, and then I can revert that back to the amp hour size of the batteries, how much we need in reserve, and how much that is. So I've always done that. Why do we want to do all this, figure this out first? Well, first of all, we have to figure out how much space we have, what we can do, how much reserve power we might need, We want to know this so that we design a system that ensures that you have a good battery system and battery bank that isn't too large or too small for what you want to do with it. So those are all the important things that I find to start with. And if we can outline those, then it's much easier for yourselves or anyone else to come in and design a system that will give you the ability to do the things you want. I've often had people come and say, well, just tell me what I need to run my boat or run my house. It's, well, what do you use in your house? What do you use on the boat? You know, oh, it's just a simple boat. I just have the refrigerator. That's great. You find that out, you start doing some work on it. Then next thing you know, the person says, well, I also have this killer stereo equipment with a big amplifier and everything else. Well, there's another 25 or 30 amps that you've got to add in. And then the next thing you find out is they're also they want to run their air conditioning. It's just a, small 30-foot boat, and they want to run their air conditioning, 3 or 4 hours a day. So now you've gone from this, how much power do I need on this boat, to how much power is needed on the boat, which is where you should be coming at that. Let's go on to the next slide. So once we've finished our power assessment, and I'm going to just show you a little power assessment after this, we're going to be able to figure out how many kilowatts we need per day. We're going to know, we'll be able to figure out what's available for our charging source. We're also going to be able to figure out the true capacity of our batteries, as well as the length of time. We know that we're going to go between charges, and you're hopefully at this point have a budget, because everybody does. And so you want to work within your budget, because putting these things in and getting to a point where you run over your budget doesn't make you very happy, and definitely doesn't help in the long run, because of course now you've got something that you may not be able to finish, or you may not be able to use, or you won't be happy with it. So always keep in mind your budget. And being boat owners, I'm sure you understand that whatever the yard says, just double it and add 50%, and it'll be close to what it'll cost you in the end. So I hope that got a few laughs. Obviously, the other thing to do with the power assessment is, when you're looking at this, is to figure out what type of voltages, whether we're going to be running in 12 or 24. You might even find more and more boats going to 48 volt, not just for propulsion, but also for the size of the wires and the battery banks. Also, when we're getting into 48 volts with inverters and chargers, we're actually becoming, they're actually more efficient, because the conversion from 48 to 120 volts isn't as great, vice versa. So we don't have as much heat loss doing those things. And obviously, with all those in mind, we can start to look at the type of batteries that we're after. Here I've done just a quick assessment. It by no means covers everything. It's just something I did to give you an example of how I work these items out. As you can see across the top, we've got, let's see if my pointer shows up. There we go. Navigation for your electronics. You're looking at take the manufacturer's numbers in these, figure out how long you're running. I would sort of did this considering, okay, we're going to go out and we're going to do an ocean crossing, or we're going to cross a couple days on the boat to the Bahamas. Well, I guess it doesn't take you a couple days to the Bahamas, going somewhere for a few days. So you can just see the kind of wattage that we're going to require if we're running these things. So you can see, nav lights, you've got to run them for 12 hours a day. You might have a microwave, and you're not going to run that very much, but that's the great thing about a microwave. As you can see, I sort of put in a 12,000 watt microwave here, which sort of takes 1200 watts to run. You'll see we draw 10 amps at 120 volts, but we're really only drawing it for half an hour. So really we haven't used very much power. We've only used 600 watts compared to our navigation that's run all day. It's running around 4,300. Kettle, you'll notice here we're running from, this is where I use the different voltages so that I end up with a set amount. This way it doesn't matter whether I'm calculating something that's running on 120 or it's running on 12 or 24. I can add those when I do this multiplication, and that's all this really is. 15 times 4 times the 12-volt voltage is going to give us this 4,320. So that's a really nice, easy calculation to do. And then once again, down at the bottom, sorry about flipping back and forth there, our total amount. So that's what we get to. That's just in my assessment. That's how much power we're going to use in a 24-hour period. Knowing that, we can start to size our battery bank. And we can start to look at how, once we have that in size, we can actually start then and going and see how we're going to do this. So as you can see, what we're starting with is the power assessment first, and then the size of the amount of power we're going to need. And then we can start adding in or taking out things like say, okay, that generator is a 5 kW generator. It's going to run for 15 minutes. And I'm hoping that I just got a note saying my internet connection isn't stable, but do let me know if I blick out here. Barb's got my email and everything, so she can take care of that. So as you can see, now we're running a 5 kW generator for a couple hours a day. All of a sudden, we're taking care of a large portion of this total wattage that we need in there.
Lance, did you want to move your slide? I think we're still stuck on, there we go.
How's that?
That's good.
Yeah. So you can see here, I've just done some very simple sizing here to give you an idea of what you're looking at when you're trying to size your battery bank. So now that we've figured out how many kilowatt hours we need, this we can see the type of battery, we can choose the type of battery. The discharge allowance, the percentage discharge, or on a lead acid battery, which is what we're talking about here, we're only discharging them 50%. So all of a sudden, basically, we need double that amount of capacity to give us our, in this case, it's going to be 1200 watts or 1200 amp hours of usage. So here you can see we need quite a significant size of our battery bank. Now, this is all assuming that there's no other charging going on at the time. So this is, like I say, this is where you start, and now we can work backwards a little bit. Lead carbon batteries have a deeper discharge floor, so we can get down to 70%. So all of a sudden we drop our sizing down. Lithium's really nice because not only does it have a deeper discharge, but it also has a higher voltage, which means our amp hours, our wattages, when we calculate our amp hours, we can actually get into lower amp hours because of that. You see on this table below, what I've done here is giving you an idea of the way of charging these things. I've taken these samples of the size. This golf cart, obviously here, this 1.08 is about the amount of power you have to put in to get, let's say if we had a 10 amp hour battery, you'd have to put in almost 11 amps into it to get that 10 amps usable out of it afterwards. So this is the factor. And then of course, lead acid, as I say over and over again, you really don't want to be charging it more than 0.1 C, which is 10% of the capacity. You can, especially in a larger bank, you might be able to push that up a little bit. Victron has done a lot of research on this. Rhino, the owner of the company, loves this sort of thing. And he has determined that a standard lead acid battery shouldn't ever see more than about 12% of its capacity as a charge to get its maximum life cycles out of it. What happens when we increase that is we're increasing, because of the internal resistance, we're increasing the heat in the battery. As the battery temperature goes up, the resistance increases and the battery temperature goes up, and then the resistance increases. As you can see the bad loop we're getting into. We need to be able to mitigate that either by reducing the voltage output. But if we stay in that 0.1 C, we can do a lot more charging for longer periods. But once again, now that we see, I've used the maximum charge current to establish how much time it's going to take us to replace 80% of the charge. Done the same with the lead carbon. The lead carbon's a little better in power in to power out. Also, the lead carbon you're going to find it's mostly in about 0.2 C. So we can charge with less. We can charge with a higher amperage. And then, of course, down on the bottom, we get into our lithium. Lithium really is somewhere between 0.01 and 0.02 for charge efficiency. Often you're going to see that expressed the other way. You're going to see it as either 95% or in lithium, it could be 98 or 99% efficiency, charge efficiency.
Lance,
Obviously, now we can put a lot of weight in that. Yeah.
two questions.
Yeah, absolutely.
One that somebody raised is, what if they were using 6-volt batteries as opposed to 12? Is there any advantage or disadvantage?
Yeah, so here we're going. This is the GC, the golf carts. The nice thing about golf cart battery, well, there's two nice things. First of all, they're designed to go in a golf cart, which bounces all over the golf course. You get all sorts of crazy people driving it all over the golf course. I'm sure many of you have seen golf carts in all sorts of precarious positions, which means it's really good for boats. Because you can tip them around all over the place, you can beat them up, and they sustain quite a bit of abuse. Also in the 6-volt batteries, because they are truly deep cycle batteries, the plates in them are thicker. They're going to give up energy slower, but more consistently. I'm still a big fan of golf cart batteries, 6 volts. Because of the way they're built, you can get 2 6-volt batteries. You can actually get 3 6-volt batteries in the space of an 8D. And that gives you basically 1.5 times the amperage capacity of that 8D for deep discharge. So you can see by your 2/3 the size for the same amount of power. That's a really good reason to use 6 volts. And I've seen 6 volts in all applications, in 12-volt applications, in 24 and 48-volt applications. They're, like I say, you're bang for your buck. If you're on a budget, there's nothing wrong with a good golf cart battery. Buy a decent one and treat it well. And if you treat it with that 50% discharge in mind, you will get 400 or 500 cycles out of it without any problem. If you start taking a golf cart battery, a 6-volt down below that, you're going to shorten the life cycle quite quickly.
Okay, and then the second question is the size of the bank that you have in the right-hand column. How was that calculated again? I may have missed it.
The size of the bank was calculated by taking our kilowatt hours. So in this case, basically 14,000 watts. And
Oops, I think we lost
go beyond. And that gives us, so here we're looking at about 1,230 amp hours is we need. But in order to get 1,230 amps out of a golf cart battery in this size, we would need to have 2,400 amp hours. So you can see that it's quite a large battery bank. This is typically when you're getting into this is where you saw all these great big 2-volt cells. And what are the L13s, the tall 6-volt golf cart batteries that have quite a bit more capacity in them, I think up to 400 and some odd amp hours. So easier to build a big system like that. Once again, it's just space and weight. Does that answer that question?
I think so, although at least my internet may have cut out just as you answered how you got to the amp hour.
No problem, I'll repeat that. So let's do the lithium on the bottom.
Sure.
Once again, that from that sizing, from that power assessment on the previous page, we're looking at basically 14 kilowatts of power we need. So that's how much power for the time of over that 24-hour period. That's how many kilowatt hours we need. So thankfully, lithium operates at 12.8 volts, so we can divide the 14, in this case 14,336 by 12.8. We can only discharge the battery 80%. So we have to take that into consideration. We have to leave 20% of the power in the lithium battery. So I want to basically times it by 0.8, and that gives me my 1439 here. So of course, in the golf cart that's at the top, basically, if we use 1200, if we're going to use 1200 amp hours, we need to size our battery bank up to 2400 so that we've got enough usable and we don't drop below the 50% discharge, and we maintain our voltage. Otherwise, at 50% discharge, this is when you hit 12 volts. As the battery gets older, that 50% discharge is going to start being 11.8. So we want to make sure that we stay in that bracket with these.
Okay, great.
Yeah, and of course, once again, the maximum charge current. And I can't say this enough. Go to the battery manufacturer. They do recommend what their maximum charge currents are. Any decent battery manufacturer will. You'll find it on their data sheets. If you stay within that, they've spent millions of dollars testing these things, or hopefully, and hopefully you can keep within that and make the battery last as long as you possibly can. So now we can go backwards a little bit. Well, keep going forwards. As you can see here, now we have some idea of how much we're going to need to charge, the kind of amperage that we're going to have to put out for over a specific amount of time. Now, of course, once again, as we talked about, if you already know that you're going to be running your generator for a couple hours a day, then we can start to take that capacity right out of the battery bank, because we know we're going to regenerate that power in a given amount of time. Also, when you're looking at generators, we always want to be running them at 80% capacity. So this is a good chance to, for example, run your water maker, maybe some air conditioning, and then maximize the charging capacity so that we can run the generators right up to their capacity. But also we start looking at, okay, so now we're going to have 6 hours of sunlight every day. How much space can we put, how much space can we have put in solar panels? How much is that going to generate? How much is that going to generate daily? We can once again start to reduce the amount of amp hours that we need in that battery bank, because once we're talking about having it for 24 hours, now what we're talking about is having the usage that we're taking out of it applied to it at the same time. So we're actually not losing that power. So we're staying stable. I put in here, you'll notice that there is, I'm going to see if I can do that. Here's a link for you to our solar charge controllers. If you go to that, you'll notice that there's actually a nice MPPT charge controller calculator. So that's a really great way to get in and size your solar panels. Since we're sitting up here at solar panels, that MPPT, multiple power point tracking, you do want to spend more money and get an MPPT charge controller. It will increase your yield 25 to 30% out of your panels. And the reason it's doing that is because you're not losing power in heat, which is what a PWM is doing. It's slicing the power off that it doesn't need, and it sheds that by heat. In an MPPT, because it's constantly adjusting itself, it's actually basically doing a DC to DC conversion. So you're going to see more power into your batteries because of that. I also put in here, because I know this will come up at some point, series versus parallel, which looks like I spelt it incorrectly. Sorry about that, folks. I always try to increase my panel voltage, sometimes at a detriment to shading. But what I've learned and found is that increase in voltage means that the solar panel or solar panel array is much more likely to start charging earlier in the day. So if you think you've got a couple of small panels, just for example, 100-watt panels, and they run at about 18 volts, because they might be a 21-volt VOC, but they're going to operate at about 18 volts. That panel has to be about, if your batteries are at 12 volts, they're going to have to be at about 17 volts to start, which means you pretty much have to have that panel operating at its maximum efficiency before the MPPT starts charging the batteries. Now, if you have two panels series together, even if we're getting some shading on them, all of a sudden our voltage is doubled, and we're going to reach that 17 volts much earlier than we would if we had a single panel or several of those panels in parallel. So a lot of times, I know Alex is good catamaran, those are great. You start playing around with the series parallel, port and starboard. If you're doing port and starboard, definitely you can play around with some parallels. Also, when you're looking at solar charge controllers, very often on vessels, we'll do charge controllers for each array, so that instead of having a larger one, we'll have multiple smaller ones, and they can all work together. They'll all charge the batteries, and you'll get maximum efficiency out of them, because when one panel is in shade and it's on a different array, it's not going to be affecting the other ones. So it's a really nice way to go with multiples, but also remember, keeping your voltage up gets you charging earlier. It also means that when you run that wire that much farther, we're not dealing with such a voltage loss because we have a higher voltage to begin with. So we've got a smaller ampacity going through the line, and all electrical lines are rated by ampacity, the voltage typically. So all of a sudden, instead of trying to push 30 amps through a 10 gauge wire, we're only pushing 7 or 8, or maybe even 6. That means that our voltage loss at the other end is less, which means that our solar charge controller is doing better work because it's got a higher voltage and can convert to more power for you. So remember that when you're sizing that. A lot of times going up by putting a couple panels in series or going to a high voltage panel, you're going to be able to mitigate a lot of those voltage loss issues, and in turn give yourself more net power. Obviously, the grid and shore power, this is a good thing to consider. How often are you how long do you go out? And we did our little power assessment as a full overnight passage, but maybe you're just going out for the weekends. Obviously, you're not going to run your navigation all that time, so that takes a whole bunch of that power out. But you might be running you might be running your beer fridge, so that's going to add power. So all those things you've got to add into that. And if you're really honest, you'll figure out how much time you're spending on the boat away from shore and how much time you're spending either up to the dock or just in that in between, or when your boat is sitting for a while. So yes, you get into that battery. Once we know that, we can also start sizing battery chargers and for where you are. I put that note in there more for me. One of the things that we're finding more and more often now is people taking their boats all over the world. This is another thing when you've got to start considering what kind of shore power you're going to have, because most inverters will not convert, well, they won't convert hertz. So if you go to another dock that happens to be sitting at 50 hertz and you're trying to run your washing machine on the boat from dock power, you might find that you have a little bit of problems, or that you burn out your dishwasher, washing machine, I should say, because those items, a lot of those items are using the hertz to actually use as clock speed in the electronics. So they're designed at 50 hertz or 60 hertz, and when you take them back and forth, you can do damage. A lot of times now what we're doing is we're designing the vessels for all one source of alternating current. I don't want to say AC, one set of alternating current. And then what we'll do is we'll put in universal voltage input battery chargers, so that when you're not in your home country, you can actually plug into different voltages, different hertz, and you won't have any issue because, of course, Victron makes many multi-voltage chargers, so that you can make sure that even when you're using the inverter to give you power, you can be charging into your batteries as well from whether it's 230, 50, or it could actually be 110, 50 hertz. But at least this way, you're always covered in charging your batteries. So identifying the grid and shore power that you're going to be connected to is important too when you're looking at how to charge. Obviously, main engines. Your alternator, that was one of the big things. So let's just go on about an alternator here. One of the things that we do in our training is go on quite a bit about alternators. We do this great little video of blowing up an alternator. Takes us about 15, I think actually about 12 minutes, because it's got a lithium battery connected to it. And of course, if you have a 12 volt, or sorry, if you have a 100 volt lithium battery, or sorry, 100 amp lithium battery and 100 amp alternator, you don't have a 2-to-1 ratio. The alternator is going to be running at full speed to try to recharge that lithium battery, and it'll overheat, especially on a boat. So we're doing a lot more with either current regulation, meaning that we're using some sort of regulator to limit the amount of current that's coming out of the alternator. Be that in our case, we have battery management systems that do that, but also now we're looking at things like external regulators for the alternator. So when you're getting into Balmar and Wakespeed and Ecomax, all those companies, not only do most of them have really nice alternators, but they also make exterior regulation, which is looking at both the voltage and the temperature of the not only the alternator, but often the battery as well. And in some of these, they're actually looking at the current they're putting out. So at that point, we can start to actually regulate the alternator so that it's always within its maximum charging capacity while it's never overheating, which means that you're going to get more generation out of the alternator. I was just down on a boat last Friday. It was running at 1,000 RPM, basically a fast idle, and we were producing 173. It was a 24 volt, 270 amp alternator, and basically at a fast idle, it was producing 173 amps. So you can see quickly how with external regulation, we can really generate a lot more power to put back into the batteries. I'm going to quickly go over wind power. Obviously, most of you, if you've been sailing for a while, you know wind generators are wonderful if they actually generated wind, but they don't. They work very well when you're anchored in the trades. They work well when you're sailing off the wind, but when you're sailing with the wind, when you lose that apparent wind speed, then we're dropping down in that. So not always a sufficient source of power. And the same with wind generators or water generators, obviously. But they are good to, if you've got those options, it's one more thing that you can start to add back into your power assessment. Now we can add things in. You're doing a crossing and it's 10 days long, and you know that you're going to be doing 6 knots all the time. And you can throw out a 200 watt water generator or 100 watt water generator. You're making that 24 hours a day. All of a sudden, we've got we've got 2,400 watts coming back in to our assessment. So that's always a nice way to look at it. Now let me just see where I'm at here. So you just want to do for an hour or longer than that? Alex, Bart?
You can go. How much more do you have?
I'm just about finished up.
Okay, why don't you finish up, and then we'll have time for some questions today.
Yeah, absolutely.
Anything else we don't cover today, we'll pick up on
Perfect.
Thursday.
So I'll just go quickly over this stuff. Obviously, what I've got in here is now that we've done sort of figured out exactly what kind of system or what size and what our needs are, we can actually start to configure the system. you can start looking at the size of the alternators you need, the size of the inverters you need for the power you're looking at, how to size, you can size your batteries properly, and of course you're going to have the size and the type that you're going to do that. Also at this point we can start looking at maximizing our charging facilities, be that MPPT, solar, alternator, generator, and main engines. So we're doing all that. I put a couple notes in here in the yellowy orange here for me to remind people. Always charge to or at manufacturer specifications. I can't say that enough. Every battery manufacturer will give you that. Follow those. Don't go into the boatyard, listen to the crusty old fishermen, but do read the manufacturers. I've also noticed a lot of people doing systems now where there is no emergency rerouting. This is going to be important on boats. If you're using a drop-in battery, lithium battery, that's the way you're going to go. Know that that battery can turn itself off, in which case you're not going to have any power, and you'll need to be able to work around that. So having an emergency parallel switch available so that you can get into your typically your start battery, your lead acid battery, for those emergency situations is quite important. Quick thing about MPPTs, and we can talk more about those later if you like. Don't oversize them. There's no point in buying a 50 amp charger if you're only ever going to get 30 amps out of your solar panels. In fact, we often oversize our array to the panel because we're trying to know exactly how much power we're going to be putting in, so we can actually figure out how much more power or the constant amount of power we're going to go into our batteries. For example, typically a lot of boats and a lot of off-grid, normally we could be going to about a 30% increase in size or oversizing the array. When you get up into the Pacific Northwest, you probably could be looking at even 50% if you want to get that 30 amps out of the charge controller all the time. You're going to size the array so that you are always getting that, even in the worst there. Monitoring, we offer a ton of monitoring for people. Sort of got in power management. Part of power management is actually monitoring it. I'm going to show you that here in a second, and then we can finally get out and leave it off. Our Victron system, many people ask me for these. This is one of our schematics. Schematics are never right because your boat isn't ever set up exactly this way, but they do give you a very general and ideal way to put our systems together. In here, you'll notice that we do have our system monitoring, which is done through our Venus system. Many of you will see that now. It'll be either a servo or a Venus connected with some sort of screen or multifunction display, and our servo, our touch screens as a choice as well. And the thing with these systems is we've started designing these systems so that they can become, instead of just a passive monitoring system, that they can actually actively work with all these different devices that we can connect to it. That's what we call distributed voltage and current control. So now we can size our batteries, we can make all these things work, and then limit the maximum amount of current and voltage that the batteries will see, so that they are within manufacturer specifications. So all of a sudden, when we're running the generator and the main engines are going, plus we have solar, maybe we have more capacity than the batteries will take, but then our monitoring systems, our Victron systems, will now be able to mitigate or manage that so that the batteries actually see their correct charging and current. So it's a really nice way to go. It also gives you the ability to see what's happening right on the screen without trying to calculate from voltage meters and current meters, what's actually going on. And I think that's basically it. How's that?
Okay, so
We're going to have some questions, I think.
yes, we do. Relevant to the last slide, I think.
Yep.
Can you clarify when you're talking? No, well, actually, the one before that.
Yep.
You're talking about oversizing the MPPTs.
Yeah.
Can you clarify what that really means?
Yeah, certainly. So when you're sizing a solar charge controller, actually what you're trying to do is figure out how much power you're going to get out of that consistently. Meaning that if you're doing your power assessment, you know that you have to have, say, just for argument's sake, we need 50 amps out of our MPPT, out of our solar array. So your solar array works really well when you're on the equator and there's no clouds in the sky, and you get this perfect 6.5, 7 hours of sunshine going across it, and the solar charge controller doing its full job, and we get our full 50 amps out of it. The issue comes when we start moving out of those farther north or south, or we're getting more clouds and we're running into shoulder season weather, being that spring or fall or even the winter. Often the winter is not so bad as the spring and fall when we've got more clouds. So what we'll do often is say, we always want 50 amps coming into this. So let's have a look at what the weather is going to be like, because we can go to NOAA and things like that and say, okay, this is the average amount of sunshine this area gets, or this is the average amount that we're going to see when we go to these places. We still need 50 amps, or say we need 150 amps through that day. We can size our array sufficiently large enough that when we have less sunshine, that it's still giving us the amount of amps into our battery bank that we're looking for. It comes much more into play in off-grid and stationary systems, but I've seen it more and more. We're in Florida right now. It's not so much of a concern here, but typically, like in the Pacific Northwest, or when you're getting up onto the northern seaboards, you know you're not going to have beautiful weather all the time, but you know that you always need to have replace 200 amps into your battery bank every day. You need to size your array, your solar array, large enough that on those shoulder seasons that you're still getting your 200 amps. And that's what I mean by oversizing. So you'll see, and in fact, most solar, the government actually has the whole website on part of their website. It actually shows you how much oversize to do. Typically, if you're in the Northeast, you're probably going to be in 20 to 30% oversize. In the Pacific North, in the Pacific, not the Pacific West, so sort of down the western coast, you're going from 20 to 30 as well. When you get a little farther north, when we're getting into Seattle and farther north than that, we could be looking at 30 to 40% increase in size, so that we always are getting that amount of amperage out of the charge controller over that day.
So you're increasing the size of the array,
yeah,
because it's not going to be as efficient, and then the charge controller itself should be still kept smaller, relative.
It can be kept smaller, and that's what that's doing is, yes, you are chopping off the top of the power when you have the best sunlight, but what that is doing, if you look at over the long run, basically what it's doing is it's spreading out the amount of charge you're getting over the whole year. And when you're on the boat, you're going to be looking at, in bad conditions. If you have to make so much solar power, if you have to say, I've done my assessment and I need to recharge at least 200 amps every day from my solar, then you have to consider the worst condition, or not the worst, but a not prime condition, and make sure that you size your array appropriately. You can always, on almost all MPPTs, you can overdrive them, meaning you can have them have more amperage, because they only give out a set amount of amperage. You can't over voltage them, but you can't over amperage them. So it's usually not to detriment of the MPPT. It's basically making sure that you get all the amps back into the battery that you need to, because you've done your power assessment and you know, if I don't get the 200 amps, I'm starting to go backwards. I'm just using 200 as
Got it.
as an example. Yeah.
So a follow-on question was asked,
Yeah.
are double pole circuit breakers required between the panel and the MPPT?
Oh boy, that's going to be an argument. There is no requirement to have any sort of fuse or breaker between the solar panel, and this is by ABYC, the solar panel and the charge controller, because the solar panel is a current limited device. And as long as you size the wire to 125% of the maximum output of current of that device, there's no requirement for you to put a breaker in it. For me, 100% put a breaker on it. Even if it is only, even if you do negative or positive only, I can tell you, if you have a system and you've got 60 or 90 volts coming out of it, you really want to turn that off if you're going to play around, because that's voltage is hair curling. So okay. Yeah, you do it for workability, for best practices. I always suggest having a breaker. Double pole is wonderful because you're killing everything. And if you can have, if you've got the space to do it, definitely. If you don't have the space to do it, at least do it on the positive. So you can, basically you can turn the MPPT, the panel array off. Doesn't hurt the array to turn it off. So that's exactly what MPPTs and PWMs do when they get to the, when you've got to, I've had this question before, my MPPT, it's bright sunny out, it doesn't work. And it's, what's voltage of your batteries? They're 14.4. Well, the MPPT isn't working because it doesn't, your batteries don't need any more charge. So basically what it's doing is it's actually turning, it's cutting the power from the panel. So it's disconnecting the circuit. Yeah.
So it just breaks the circuit essentially.
Just breaks the circuit. Yeah, exactly what it's doing.
The complex diagram that you showed at the end, asked the question, is there a way of getting the icons so you can make up your own drawing?
No. We get asked that all the time, and the company policy is that those diagrams are not, they're not open to the public.
No, I guess the only thing you can do is kind of make little pictures of them. And
the really nice thing to do is if people go on to our website, you can find all the pictures that we use on the website. They're in the downloads section of our website, and all the pictures are there. So you can actually grab those pictures and start using them yourself. That works really well if you're playing with it like a PDF file or something like that. You can do it with that. When you're trying to get into a Visio or something like that, it gets a little bit harder. But there are a couple of really good Smart Draw and what's another one there, and where you can actually start importing those and using them because they're pulled off as a PNG or a PDF. So, but the short answer is no, that our Visio stencils are not available to the public.
All right. Another question is, can you set up an alarm when the batteries reach a specified percentage of discharge so that you can modify your usage or engage?
Yeah, absolutely. It's actually one of the very nice things about the BMV, the 712, actually any of the 700 series, not the Smart Shunt, but the others, they all have, they have an alarm on them. And you can set that alarm. You can either have it make its a little sound. It's a very small alarm on the back of it. It'll go beep, beep, beep. Or you can set the relay that they have on them to ignite or to excite a larger alarm. And you can set that to state of charge. You can set it to maximum current draw. You can set it to battery voltage. so that you can actually have an alarm going off telling you that you're at, if you don't want to go below 50% discharge, you could set it at 55, so you get an alarm beforehand. If you've got lithium batteries and you don't want to go below 80, you might set it at 70 or 75% state of charge, or you might use a voltage, and all three of those battery monitors will do that. So that's
Yeah. I'm not quite sure I fully understand this question, but it basically, is it easy to add a second charger if you find more shore power is needed? So I'm assuming he means adding a second inverter to give you additional AC.
Yeah, definitely. There's a number of ways to do that. Often when you start looking at this, the cost of an inverter and the cost of an equally sized DC charger, you get a lot of functionality by having a second inverter. Obviously, you've got, if your battery banks are sufficiently sized and you can take that extra power, you can also create that extra power. But really, for what amounts, if we're talking about a couple of multi-pluses, what amounts to about another $300, you have an inverter charger as opposed to a 120 amp charger alone. The other thing too is looking at some smaller chargers. What we've done now with our smart blue chargers is they will actually they'll talk to each other through Bluetooth as long as they're close enough together, and they synchronize their charge together. So you can actually, if you wanted to make up a 120 or a 90 amp charger, you could buy 2, 3, or 4 of the 12 by 30s in the IP22s, and they'll actually communicate with each other and synchronize their charge. So they all switch from bulk to absorb to float to standby at the same time. So
all right,
that makes it, yeah.
Okay. Have you or anybody else had any experience with, I guess, a propeller shaft driven alternator as a source of power?
Yeah, actually I have. It's one of the boats I cruised on. Yeah, they work. The one I was on was beautiful. It had a controllable variable pitch propeller. So basically what you did is you freewheeled the propeller, disengaged it had a mechanism to actually disengage it from the transmission, because don't forget that transmission, you got to make sure that the transmission isn't damaged by the shaft turning over, because there's no oil being forced through it. So that's one thing to have a look at. But what we did is it was just a basically big alternator on top of the shaft on a serpentine belt, on a cog belt. And once we got going, we just started slowly feathering the propeller until we got the correct RPM out of the alternator. Worked really nicely. And once you set yourself on a heading and you're going to maintain a certain speed for all the time. If you're losing a quarter of an eighth of that, that really depends on the size of the boat. But if you're losing that kind of knots over the long haul, might mean that you have to stay out an extra day. Hopefully you've brought enough beer with you.
Yep. Okay, we had another question about the Victron DMV 712.
Yeah.
Is that the best Victron battery monitor, or are there newer ones?
I think so. The smart shunt is really great if you don't want the dial. I love the dial. The 712 also has the relay built into it, which the smart shunt doesn't. So you can use the relay you can actually use the relay to do generator starts. You can use it to turn things off. Anything you think you want to switch with what the BMB, the information that it's got, you can use to turn that relay on and off, be that an alarm or turning on a generator or turning off a refrigerator or something like that, or freezer. I've seen all those uses. I like the 712 because to me that little dial is always on. Anybody walking by can see it, so you're not trying to explain to people, okay, get your phone out, look at your app. I don't know about most of you, but when I go sailing, I like to put my phone down. Sort of for me, that's a getaway. So you can put it down and you can always see the time remaining or your state of charge or your voltage, whatever you want to set on it. And it's always there and everybody can see it. So it's a really, I find that that's a really nice, and that dial is the same size as most, and well, it's a 2 1/16 inch dial. So that's the industry standard. So it looks really nice on a power panel. And like I say, it's easy for everyone to read. It's just to me, yeah, I think that's the best version. And quite honestly, it's for, I mean, I really believe it's the best price battery monitor that's out there. You can look at some of the other competitors, and if you're looking at anything that does anything near to what ours does and how accurate it is, you're in the high to $300, almost $400 for the battery monitor. So.
Okay.
It's your gas gauge.
Yeah.
Your fuel gauge, right? Every boat should have one.
So you mentioned we don't really know what the life
Lifespan of lithium is.
Lithium. We don't know really what the life of lithium batteries are going to be, whether it's, so what's your indication that they are starting to die?
We've tested ours to 3,500 cycles now. That has taken almost 10 years. Okay. Because there's 356 days a year, and to do a cycle, we need to completely discharge the battery and bring it back up charge. So typically a cycle takes about 28 hours to complete. So we have been testing, and now remember this, we're testing batteries that we made almost 10 years ago now. And the cells and the products that we use now are only better. And so there's always a lot of theory in them, and a lot of computer modeling, but that's why I said we don't know how long they're going to, because we're getting reports of people that have put more than 3,000 cycles on them already, and the batteries behave almost as though they were new. So now I've seen people kill lithiums as well. It's not hard to do that either, but typically, if you treat the battery the way it's supposed to be and the way the manufacturer says, yeah, there's no reason it won't put up those cycles. So so now all of a sudden we're talking 10 plus years. Well, think of it as if you're not living on the boat, you're not cycling it every day, we could be talking about batteries that'll last you 20 years, basically, probably beyond, kind of like the motor of the engine or the motor of the boat, right? Beyond the use of the boat owner. So yeah, it's and when that's when we start doing the math and saying, okay, so how expensive is lithium? Well, if we got rid of 5 battery changes and the labor to do that, and the amount of energy you save when you're recharging it, because we can recharge it faster. So
okay.
Yeah.
Great. Anybody have any other questions at this time? If not, going once, going twice for today, I think we will we'll wrap this session up. And again, Lance, thank you very much. This has been great. And we'll see you again on Thursday. And we'll open the floor to Barbie will wrap up, and then we'll open the floor to any other questions that anybody has.
All righty, I'm going to go ahead and stop the